Hey, what is up, guys? Eddie here, and today I'm going to talk about my Chapter 12 portfolio. Let's get started. So starting off with Chapter 12.1, functions of two variables, essentially what this section is testing for is your understanding of what an axis is. The x, y, and z axis to be precise, and if you know your shapes. Question 4 tests your understanding of an axis because you must convey and conceptualize where each of those 3 points lie on the graph. To take this idea one step further, question 16 does just that. It combines what you did in question 4, but this time you're adding shapes to the mix. However, this question is what we like to call a walk in the park, or in math terms, traversing the axis because of how easy it is. Question 16 is a good representation of what this section was about because of what you need to know to solve this problem. Because not only must you understand what an x, y, and z axis is, you must also understand that a sphere has the same radius all around. I know, crazy stuff. Moving on to section 12.2, graphs and surfaces. This section tests your understanding of what functions look like as graphs. And whoever decided to make it where you can't use a calculator or a computer to graph these problems, all I have to say is that you can't control me and I do what I want. Moreover, question 6 makes you graph 5 equations, which in this chapter is arguably the most important concept, because by graphing and knowing what each equation should look like, you're making everything a lot simpler moving forward. Likewise, question 19 makes you visualize and graph equations cross sections. This problem goes back to the idea of 2D graphs, so essentially chapter 12.2 covers everything you need to know about graphing 2D and 3D graphs. Moving on to section 12.3, contour diagrams. This section adds on to what you've learned in section 12.2 and makes you think about contour diagrams, which are three-dimensional surfaces by plotting constant z slices on a two-dimensional format. For example, question 16 makes you match the diagrams with their respective contour diagrams. However, this section does more. Not only does it introduce contour diagrams, it teaches you to interpret what those diagrams would look like in real-life applications by using data. A good example of this is question 27, where you must use the contour diagram to interpret the data and convey what these points on the diagram represent. Overall, section 12.3 is extremely important to know and understand. Section 12.4, linear functions, is arguably one of the most annoying chapters because it combines chapter 12.1 and 12.3 and also combines what you learned in an old trigonometry class. So I guess that class wasn't useless after all. Section 12.4 makes you think of how linear functions could be utilized in the three-variable space. For example, question 10 has you find an equation of a linear function in the three-axis plane, which isn't difficult because this problem usually uses mostly your ability to problem solve. Question 15 uses what you learned in 12.3 with respect to contour diagrams to interpret the data points. Likewise, you will also use Algebra 2 to solve the system of equations, which is a real blast to the past. But overall, section 12.4 is one of my favorite chapters because it ties everything you have learned in previous math classes and sections together. However, section 12.5, functions of three variables, is a step up from section 12.1 because instead of two variables, you're using three. Likewise, I would like to mention that section 12.1 also used three variables, so whoever named that chapter needs to be fired from writing titles for sections. I hate this section, mostly because it's a section 12.2 in disguise, because it makes you match more equations to their respective level surfaces, like here in question 1. However, even though this question is annoying, it's quite important because it has you understand how similar equations can change how a graph looks, like we did in section 12.2 and 3. Section 12.5 teaches you to visualize level surfaces and teaches you how to use various equations to find formulas for level surfaces. Question 4, for example, ties in section 12.1 with your understanding of what a radius is and what that means with respect to the equation of a sphere. Moreover, question 4 tests your understanding of vocabulary, like as used in the problem, quote, centered at the origin, and like my love life, centered at the origin means it will be 0. All in all, section 12.5 is very important because it gave us practice with solving equations and visualizing what those equations would look like. Section 12.6. Section 12.6. Limits and continuity is like that one cousin you don't like and don't want to see, but still, you see them at every family event. Section 12.6 ties everything that you have learned in Calc 1 and 2 and has you solve for limits and makes you show if a limit exists or not, as shown in question 16. However, this section is probably one of the most important sections in the chapter because it ties together section 12.1, 12.2, and 12.4. And since chapter 12.5 is a carbon copy of 12.1, it will be included. I would like to mention again that I hate section 12.5. Anyways, question 25 ties in this chapter very well because every large idea taught in this chapter is used in one problem, like visualizing what the functions are and what they should look like, to the understanding of points on the three variable graph and your understanding of what a piecewise function is and how they work. Overall, the central theme of chapter 12 is conceptualization and knowing your fundamentals. Conceptualization because of the planes, lines, and graphs that you need to know the shape of, and fundamentals because of the algebra you need to apply, the idea of limits, to the idea of knowing what a graph of the points should look like on an axis. And don't forget the most important part, knowing the alphabet. Because I can't tell you how many times I've had to sing the ABCs because I forgot what came in first with I, J, and K. Well, thank you for listening. I'm Eddie, and see you next time.